All right, in this lesson, we're continuing Note 6-2, different forms of quadratics. So in the previous lesson, we talked about vertex form and factored form. Today, we're going to talk about standard form, or in this lesson, we're going to talk about standard form. So standard form is f of x equals ax squared plus bx plus c. We're used to seeing a quadratic written like this from our previous unit where we learned how to factor quadratics written in standard form. So starting with the concavity, just like with the other forms, the value of a is going to tell us the concavity. So if a is greater than 0, meaning we have a positive a value, that means we're concave up. And then if a is less than 0, meaning we have a negative a value, it's concave down. The next characteristic we can easily get from standard form is our Y-intercept. So the value of c is going to give us our Y-intercept. Okay, the reason that's the case is we know that the Y-intercept, the x value is 0. Well, if we plug in 0 here and 0 here, we're multiplying by 0 in both cases, which eliminates the first and the second term, which means that the y value would have to be whatever the value of c is. So that's why the y-intercept is always the value of c. Okay. The other characteristic we can get from standard form with a little bit of calculations is your axis of symmetry and vertex. So just like with factored form, we can get the axis of symmetry doing a little bit of calculations. So the formula for the axis of symmetry when a quadratic is written in vertex form is going to be x equals negative b over 2 times a. And we also know that when we have the axis of symmetry, we also have half of our vertex, which means our vertex is going to be the axis of symmetry, comma, and then the y value of vertex. So just like with factored form, the way that we're going to find the y value of the vertex is we're going to plug in our axis of symmetry to our equation. Okay, so let's take a look at this example. It'll make it a little bit more clear. So first of all, identifying a, b, and c. Well, a is a number in front of x squared, so that's going to be negative 2. B is a number in front of x, that's going to be 4. And c is our constant term, that's negative 5. So starting with concavity, we know we look at the value of a. A is negative, so we know that we're concave down. Our y-intercept, we are going to look at the value of c. The other thing we can think about is if we plug in 0 to this equation, this becomes 0, this becomes 0, and we're just left with negative 5. So that's why it's going to be 0, negative 5. It's our y-intercept. And then to calculate our axis of symmetry, we're going to use our formula x equals negative b over 2a. So it's going to be negative, b is 4. So anytime we plug something in, I'm going to put it in parentheses so I can keep my negative straight. So negative b over 2 times a. So the numerator just becomes negative 4, and the denominator becomes negative 4. And negative 4 divided by negative 4 is 1. So my axis of symmetry is x equals 1. Well, since I know my axis of symmetry is x equals 1, I have half of my vertex. And then to get my other half, I'm going to take this value and I'm going to plug it in for x in our original equation. So I'm going to plug in 1. So f of 1, meaning we're going to plug in 1 for x. Negative 2 times 1 squared plus 4 times 1 minus 5. Well, negative 2, so 1 squared is 1, so this is negative 2. And then 4 times 1 is 4, so plus 4, and then minus 5. So going from left to right, negative 2 plus 4 is 2, and 2 minus 5 is negative 3. So my vertex is going to be 1, negative 3, which we can see here from our graph. So there's the vertex. Our y-intercept is 0, 5, or 0, negative 5, and we can see our axis of symmetry is x equals 1. All right, let's just do one more example. This is actually directly from your homework. So starting with concavity, we know that this is the value of A, this is the value of B, and this is the value of C. So starting with the concavity, since A is negative, we know that we're concave down. Our y-intercept relies on C, or we can plug in 0 for x. So this becomes 0, 0, and we're just left with negative 35. So my y-intercept is 0, negative 35. My axis of symmetry is going to be negative B over 2 times A. Okay, so again, putting parentheses so I can keep my negative straight. Negative B, B is negative 16, so that becomes positive 16. And 2 times negative 2 is negative 4. 16 divided by negative 4 is going to be negative 4. So my axis of symmetry is going to be x equals negative 4. And then if I have my axis of symmetry, I have half of my vertex. To get my other half, we're going to plug in negative 4 to this equation. So f of negative 4 is going to be negative 2, and then negative 4 squared minus 16 times negative 4 minus 35. So I'm just going to put that in my calculator all at once. So I have negative 2, parentheses, negative 4 squared minus 16 times negative 4 minus 35. I get negative 3. My vertex is going to be negative 4, negative 3. All right, so now a couple of the practice problems here, or the homework problems. So starting with number 2, so we're going to identify the concavity. So concavity, A is positive, so we know it's concave up. For B, we're going to identify the y-intercept. The y-intercept, we look at C. So my y-intercept is going to be 0, 34. For my axis of symmetry, I'm going to do the work over here. So my axis of symmetry, it's going to be negative B, so B is negative 16, over 2 times A. So that's 16 over 4. So my axis of symmetry is x equals 4. And if I have my axis of symmetry, I have half of my vertex. And to get the other half, we're going to plug in 4 to our function. 2 times 4 squared minus 16 times 4 plus 34. For that, I'm going to use my calculator. So 2 times 4 squared minus 16 times 4 plus 34. So we get 62. So 4 comma 62 is going to be my vertex. Sorry, I just realized I had a typo. It's not 462 because this should be 16. There we go. 4, 2 should be my vertex. So let me fix that. Oh, shoot. Oh, I erased it. Shoot. So it's going to be, for my vertex, well, as we saw, it's going to be 4, 2. Had a typo when I originally plugged it in. It would be 4, 2. All right, starting with number 5, I'll do this one a little nicer. So starting with concavity, A is negative, so we know it's concave down. Then B is our y-intercept. Our y-intercept is C, so it's going to be 0, negative 32. And then for my axis of symmetry, it's going to be negative B over 2 times A. So that's going to be negative 24 over negative 8. And that's going to be positive 3. And now I have half of my vertex. So it's going to be 3 comma. And to get the other half, I'm going to plug in 3. So negative 4 times 3 squared plus 24 times 3 minus 32. Sorry, I'm getting a little sloppy here. So negative 4 times 3 squared plus 24 times 3 minus 32. So I get 4. So the y value of my vertex is going to be 4.